Welcome to the fifth and final day of me annoying you, aka your 7-day Python bootcamp. All you guys will be left off with after this is a mini project that will be assigned to you soon, hopefully by tomorrow morning, or if I finish my work early enough, tonight. Well, I thank all of you for staying with me for so long. I have not prepared a speech, I'm not going to shed any tears, but it was a fun experience. Sharing what I know with you people was quite fun. And thank you for being interactive, right? Today, since it is day 5, I've saved Matploitlib for today, Matploitlib, whatever you want to call it. Let's quickly revise what we did yesterday, though. We did pandas yesterday. Is there anyone who could not attend yesterday's session? Ravi, okay. We did pandas yesterday, Ravi, and it's not the animal. It is a module in Python which we can use to alter files. We can handle files with it. We can import files. We can delete data sets. We can create new data sets, etc. I'll show you how it works. All right. Give me 1 second. I am going to share my screen. All right. All right. If it is available, just someone say yes, please, or something. Is this visible? Can you guys see this? Hello.
Yes, it is visible.
All right. Thank you. Yeah. So we did series in pandas before. Pandas. There we go. First main data type we will learn about in pandas is series. And what series is, it is basically a collection of some consecutive items. They will come after one another and they need to be of the same size so we can assign each other with each other. You can change their label names, you can change their values, you can view columns, rows specifically. And you see here that we've created labels, A, B, C, we've created a list, an array, which is a NumPy array, and a dictionary. And we see that using pd.series, we can create a series for whatever data we put in here. So let me run this code first. Now, since here the data is my underscore list, you can see 10, 20, and 30 based on whatever I've put over here. If I alter this data, I put hi, comma, hello, comma, sup. You see the list changes accordingly, right? 1 second. That's better. So you see the list changes according to whatever the values are that you give here, right? Then you have array is equal to numpy.array of 10, 20, 30. And you see if you print this array, see 10, 20, 30 come up. Again, let's say I don't like the 0, 1, 2 indexing over here. I want to change those names. I'm going to replace them with labels. Whatever labels I've decided I want to name them as, I'm just going to do that. And it will change A, hi, B, hello, C, what's up. There we go. Similarly, instead of data equals my list and index equals labels, I can simply put my list, comma, labels. pd.series of ARR gives me a series with the array data type and doesn't bother me anymore. pd.series of D gives me the dictionary as the values. Now you see, in a dictionary, you have A assigned to 10 and B assigned to 20 and C assigned to 30. Now A, B, C are the key values. 10, 20, 30 are the actual weighted values. Therefore, all of the keys will become the indices and all of the values will become the data. I hope this is understood. We discussed this yesterday. Then we saw how in a data in series, we can hold a variety of object types. We can hold, well, obviously data labels. Then you can hold functions as well. Sum, print, len, pow, max, min, all of these are different functions in Python. And I've created a series just for them. So cute. using an index. Now we can index these series that we create, right? Obviously, you saw how I labeled them with 0, 1, 2, 3. I changed them to A, B, C. I'm going to change them to USA, Germany, USSR, Japan. And you see I've created a series called Series 1 and another one called Series 2, which I've assigned to USA, Germany, Italy, and Japan. You see that there's USSR here and there's Italy here. And that, my friends, is called politics. And now we can see two different series is printed here. I want to see the exact data assigned to Italy. I just do series 2 of Italy. If I want to see the exact, oh God, I want to see the exact data assigned to USSR. Go to this. First thing I need to do is run these codes. And boom, see the assigned value to USSR is 3. You can see that over here. Checks out. Operations are also done off of these indices. Series 1 plus series 2, series 1 minus series 2. And you see the NaN values here. What this NaN value refers to is that this item does not exist in both the series. Therefore, a proper mathematical operation cannot be done for these objects. You can see in USSR as well, excuse me, USSR as well, it doesn't exist in one series, but exists in the other. Therefore, you have the value NaN assigned to it. Same goes for Italy. And when you subtract them, obviously, since they're the same values, you're subtracting 1 minus 1, you get 0. You get 68 minus 68 will be 0. Obviously, any value subtracted by itself will be 0. This is what we did yesterday. And I close this. You know what? I'm going to save this and there we go. Then we went through data frames. Data frames are basically a bunch of series objects. I've clubbed them together and I've given, okay, someone has it out. Ravi, your hand, why is it still up? It is not up. Does anyone have a doubt with series? Oh, prayer, right. We got data frames, which are basically a bunch of series with combined indices. You have a row column based data set and you can access them however you'd like to. Now I've created a data frame over here. I've used numpy.random.randn, right? And I've also created a random seed for it, obviously, which refers to, oh, 1 second, refers to how the data will be selected. Now this fixed data set would always be same unless I run randn again, okay? pd.dataframe of random 5,4, which creates a 5 by 4 matrix with random standard distribution values. Index will be A, B, C, D, E dot split. You can just put A, comma, B, comma, like, comma, B, comma, C, or you can do the smart thing and put A, B, C, D, E dot split. Dot split was discussed earlier. It essentially splits a string into multiple individual units based on whatever character you give it. By default, the character is space. So you see the spaces over here. These spaces are split to change them into individual strings. So you got ABCDE dot split and columns equals WXYZ dot split. Then you look at DF and it is a very beautiful data frame. Okay. Selection and indexing. Let us learn the various methods to grab data from a data frame. Of course, df of w will give me that particular column itself. I run this, I get that column. I don't want w, I want y. And I have y, 907969. Nice. Then we have z. Whatever, like this, you can access whatever column you want to. Note that there are two sets of square brackets over here. Now, if you want multiple column names, www, if I want wyw, I want wyz, I don't want x. Now I want xyz, I don't want w. I can get them however I want to. All right. Type of df of w. Now you can see what is this row w, sorry, this column w. It is again a part of a series, so it is just a series. That's what you see. If I do type of df, shows you that it's a frame.data frame. But again, any data type inside the data frame itself will be a series. That is how we get the definition of a data frame. A data frame is a bunch of series objects put together. Khatam. You have multiple series. You have one W series, one X series, one Y series, one Z series. You're clubbing them together and DF becomes your data frame. That's it. Then we have a new column. We can create new columns just like this. Just add them. Khatam. Right? And let me do this. And there you go. You have a new column here. If you want to remove your column, you can remove them, but it won't take place unless you specify it. For taking place of this, you need to do in place equals true. Now, this is a common line that you need to remember for data frames. Whatever changes you make to your data frame, it will not matter unless you slap it and you have to tell it that it has to remain in place. So whatever changes you make, regardless of how big it is, how small it is, if you do in place equal to true, then you see, oops, what's happened? Is equals true, new not found in access. I just created a new. Why are you crying? There we go. So now you can see here, I created a new axis, then I dropped it temporarily, but it still exists. Then I said in place equal to true, and then it got removed. Now, it doesn't matter how many times I do df. Oh, God. Our new column is gone. It is dead. Rest in peace. Can also drop rows this way. Instead of axis equal to 1, what you do is simply change axis equal to 0, and you can drop a row. Now you see, I dropped E. You cannot see it here anymore. But if I do df again, I see E over here. Why do I see E over here? I don't want to see E. So I do df.drop of E, comma, axis equal to 0, comma, in place equals true. If I do that, and then I look at df, boom, you can no longer find the E row. Okay? I hope this is understood. It's a very simple concept. I'm simply going through pandas today, like just one quick revision of data frames and series. That's it. I'm not going to go through missing data and group by because they're easy. And I'm going to go through merging, joining, concatenation, and operations today, because these were the two topics that I could not cover yesterday. And then we're going to move on to Matploitlib. This is graphing. This is going to be fun. Okay. Then if you want to look at rows, before we could see columns by simply doing df of w. But if you want to look at rows, you do df.loc of c. Loc is nothing but locate. Or instead of loc, you can also do iloc, which is index locate. Now remember here, I dropped the E axis, the E row, sorry. So what if I run this? Any idea what will happen if I run this? Because 4 will be E, no? 0 is A, 1 is B, 2 is C, 4 will be E. What will happen if I run this code? Okay. Guys, I am waiting for a response. You can simply put out a guess, it does not matter.
Can you once again show the
Yeah,
data
sure.
frame?
Yes, so this was your data frame originally. Okay. I dropped the E axis and I put in place equals true. Then I told you that df.iloc will locate your indexed row. But since I dropped it, any idea what will be the output of this?
Error, out of range, out of index.
Yes, you are correct. Index error. Since this does not exist, the computer will be very confused because it does not know what it is looking at, what it is pointing at. Memory may, there is one empty spot where 4 is supposed to be. I do 3, anything else, it works. I do 0, it works. I do -1, it should work as well. But it will not work for 4 because 4 no longer exists. Rest in peace, 4. df.locate of c comma w. So in row C, column W, what is the value that I have? -2.01816, and I can confirm. -2.01816. There we go. Okay. Conditional selection. An important feature of pandas is conditional selection using bracket notation. And this very similar to NumPy. df less than 0. You see, whatever values are considered to be less than 0, it will show us, well, not less than 0, it will show us false. Whatever is considered to be less than 0, it will show us true. See, this is negative. True, it is less than 0. This is negative again. True, less than 0. So on and so forth. And if you do df of df less than 0, it will give you the exact values which are less than 0. Now you can actually judge. See, 1, 2, 3, 4, get on the numbers. 1, 2, 3, 4, 5, 6 values are negative. Okay. Now df of w greater than 0 gives you all of the values with regards to w which are greater than 0. Just with regards to w. In C, you see that there is a negative value. Therefore, that has been omitted. Why? Because regarding w, that is not greater than 0, that is less than 0. If I do this, it will only show me 0 because in w, there is negative value. If w says yes, everyone else has to say yes. And if w says no, everyone else has to say no. This is called politics. df of w greater than 0 of y. Now, only in y you want to view this data frame. Whatever is greater than 0 in w, but what are those values in y? Therefore, you have these. You can see in this, you have y column, and you've got the same values over here. That's it. Y comma x, you're just seeing another data, column instead of just y. I want to see z as well. Boom, I got z as well. Okay. With two conditions, you can use or and with parentheses. These are no longer straight line and, they're or and, they're logical gates. So df of w greater than 0 and df of y greater than 1. And again, we have no such values. Say or. There we go. Here, either the values of df of w are greater than 0 or the values of df of y are greater than 1. You see that there's some negative values here, obviously. Don't be sad. Because the values of df of w are greater than 0, these have to be satisfied. It's an or condition, right? Either this or that. More index details. You can reset the indices. Whatever the A, B, C, D, E was that we had set on top over here, we don't need it anymore. We can change it. We can reset it and enable another column called it A, B, C, D, E. Under index, and again, you're back to your indices 0, 1, 2, 3, 4. Very easy to understand. I've created a new set of set of values and called it new end, which is a new list. And then I've added another column called it states. Now I want these states to be placed over here instead of the A, B, C, D, E, 0, 1, 2, 3, 4, whatever. I don't like them. Therefore, I simply do df dot set index of states, just opposite of reset index. You've reset index, you've removed everything. Now you're setting an index. There we go. But you see that it has not taken place yet. Even though you've done it here, as long as you don't do in place equals true, your changes won't take place. That is the end of that. Okay. No matter how many times you run it. Delete that. Multi-index and index hierarchy basically shows how many times you can bring an index. Like one index can contain multiple indices, and that index can contain multiple values. Basically, so we have an outside list called G1, 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 G2, G2, G2. Why? Because whatever the values are inside here, I want to group them into two segments, G1 and G2. Then again, inside we have 1, 2, 3, 1, 2, 3, which means under G1 group, I've got 1, 2, 3 as the inside indices, and G2 group, I have 1, 2, 3 as the inside indices. There we go. Higher underscore index equals list of zip of outside comma inside. So you've just combined these two lists. You've created an index. Okay. Then you do this pd dot multi-index dot from tuples of higher index. Since you've created this new tuple, you pull out a multi-index from pandas and you do the from underscore tuples function and you name whatever your tuple is, right? Then you look at it like this, and then you create a simple data frame under this using random values that you've made. Higher underscore index is your index and columns are whatever you want to call them. Say A and B. So run these codes again. Boom, boom, boom. And you have two columns, A and B, with all of these values. See, G1 has 1, 2, 3. G2 has 1, 2, 3. Okay. Now again, I want to look at the location. Sorry, I want to locate all of the rows in G1. I do that. I have all of the rows in G1. 1, 2, 3, A, B are the columns. I want to do df of by. That gives me the column B. It was previously named by, so it's still like that. Now df dot locate G2 dot location 1, which means in the G2 segment, I want the first location. Okay. And you see A is 0.166 and B is 0.184. Checks out over here. df.xs of G1. That just gives you every value present inside G1. All right. df.xs of 1, comma level equals num. Now I'm pretty sure num not found will come up because I have not named these indices yet. There we go. Now under level num, under this level, what the values are without these are grouped under G1 and G2, correct? That is how you view them. Under level num, see these values, just the first ones. And 0.166 and 1. There we go. That is all there is to data frames. I hope this is understood by everyone here.
Yes.
All right, thank you. I will close this now. You know what? Save and close. I will go through merging, joining, and concatenating. You know what? I will finish Matplotlib first, since that is something I need to complete. After you've understood that, I will come back to this. Also, everyone, I'd sent merging, joining, and concatenating yesterday. Are there any doubts in this PDF? If you've gone through it, that is. Because if there aren't any doubts, then I can move on to Matplotlib. Okay, I got one thumbs up, and that is enough to convince me. Sorry? It must have been an accident. No problem. I'm going to close this and I'm going to close this. Let us go for Matplotlib. Now, wait, you know what? Let's look at the rock for a second. Going to open that. Matplotlib and what it can do. Basically, displayed mathematics. That is all Matplotlib is. Remember doing graphs in class 7, class 8, class 10? The fun kind of graphs, not the boring kind of graphs where you have to keep drawing lines, but the fun kind of graphs where you can actually know where the line is about to go. Stuff. That is what Matplotlib is. And I'm assuming most of you guys are freshers, but if you're going into your second semester now after this, you'll have a subject called MATLAB that you'll all have to go through, right? Does anyone here know what MATLAB is? Just raise your hand, please.
We
Yep.
also have it
It's
in the first
actually in
sem
the
also.
first semester itself.
Oh, it's in first semester itself. Okay, I forgot. My bad. Yes. So everyone here, I'm assuming, knows what MATLAB is. Right. Okay. Thank you. So you know what MATLAB is. It is basically a very boring mathematical programming language that has some uses and is quite fun to depict graphs in. Right. You can create a graph like x comma x square, y comma y square, and you can just display the graph however you want it, whatever color you want to change. Well, imagine that copied and pasted into Python. That is what Matplotlib is. So you did MATLAB in your first sem. Now you'll do it again in Python. What is Matplotlib? Matplotlib is the grandfather library of data visualization with Python. It was created by John Hunter, which is irrelevant, but it's nice to know. With the intention of trying to replicate MATLAB's another programming language, plotting capabilities in Python. And if you ask what MATLAB is, it is essentially a powerful plotting software that lets you plot out. You guys know this. What can you use it for? Some of the major pros of Matplotlib are easy to get started with simple plots, support for custom labels and text, great control of every element in a figure, high quality output in many formats, very customizable in general. Now, you can obviously install Matplotlib using conda or pip, and one of these commands will work for you. Okay. Your first graph. This is where the code comes in, which is why I'm going to Alt Tab and go here. There we go. Once you've installed Matplotlib and everything's done, you have to import matplotlib.pyplot. Now, I don't have to explain this name. It's literally Python plotting. There we go. And this is a object name. PLT is the most commonly used object name. You can name it whatever you want to. You want to name P8, PT, PL, LT, up to you. But PLT. Then you do percentile matplotlib inline. What this does is it tells the Python compiler that whatever the code you're generating, Matplotlib has to execute the code within the section itself, within the compiler itself, and generate all of the graphs below. Like wherever your code is, it will generate it below it. That's it. That line is only for Jupyter notebooks. If you're using another editor, you'll use plt.show. Okay. Here, in order to display, we use percentile matplotlib inline, and you use plt.show wherever else. Okay. And there we go. Let's start. Basic example, let's walk through a very simple example using two NumPy arrays. Now we have import matplotlib.pyplot as PLT, percentile matplotlib inline, let's move that there. Import NumPy as NP, that is just for your data set. X equals np.linspace of 0, 5, 11. Now, any idea what the value of X will be? Dial back to your NumPy class.
Values from 0 to 5 with 11 divisions.
with 11 divisions between them. Perfect. Yes, you are correct. 0, 0.51, 1.52, 2.53, 3.54, 4.55. That is exactly 11 divisions between 0, 5. Okay. And y is x squared. So whatever values you have here, it's just squared. There we go. Now, what if I wanted to plot a line showing x and y? Like, how do they differ? What I do is plt dot plot. Now, your dot plot function refers to, sorry, was someone trying to speak in the middle? Okay, it's a mistake from some or something, or maybe I'm hallucinating. Now, plt dot plot x comma y comma r. Now, r here is the color red. I can change it however I want to. Let me just see if this works, and therefore it seems to see it works. Let's change it to G. Boom, we have a green colored line. I don't like how green's looking at me though. I want blue. We have a blue colored line. I want to remove all of these. I want to put a black line. Let's put black over there. Screw this. I want a yellow line. I keep hearing someone try to speak. I'm sorry if I'm interrupting someone. All right. Okay, so whatever. Here you can change your color however you'd like to change it. Just gonna put it red. X label, Y label. These are functions for your for naming your X label and your Y label, obviously. We got X-axis title over here and Y-axis title over here. And your main title is shown by plt.title function, which is your string title here. So let's say um hello, I guess, and hi, boom chicka boom boom. There we go. You got hello, hi, and boom chicka boom boom. Nice. Now this is one plot on one canvas. What if I want to create more than one plot in a single canvas? Just make it a little bit more interesting. I
Hello.
use, yeah, what's up?
Yeah, sorry to interrupt. I was just asking that changing the color does include any case sensitive things like R capital and then ED in small. Will it do something or it's the same thing?
Oops, sorry. Does that answer your question?
Yeah, thank you.
No problem. There you go. Matplotlib is pretty cool because when it comes to colors, it is completely unbiased. It just doesn't give a shit. No matter what you write, if it is a color, I don't know if purple. I come in. Oh, they have purple. Okay, I'm getting distracted. Go back to red and let us continue. Multiple plots on the same canvas. We use something called subplot. Now here you can see a regular plot. Now a plot within a plot would be a subplot, and therefore we have the subplot function of 1, comma 2, comma 1. What you've done is you've created number of rows, number of columns, and plot number. Okay. So this is, you have one row, two columns, 1 and 2, and this is your first plot number, right? Pretty sure if you miss any of these arguments, you will be scolded at all. Then you have plt.plot of x comma y comma r dash dash. What is this dash dash? You see the dashed line over here? And what about then you have another subplot? What about this g star dash? What if I create another subplot? Let's say plt dot subplot of 1, comma 2, comma 3. Then plt dot plot of x, comma y, comma b dot dash. Wait, what must be an oh, it does not handle it because that's the maximum number of columns. All right, my bad. But let us just run this code. Let's make it p dot dash. You see how the stars were changed with dots? If I just do dash, that's just one line. If I remove the dash, it's still a straight line. If I do dot, it gives me a dotted line. If I do star, it gives me stars as lines. Certain characters work over here. Even a comma works over here, I think. Yes. You see very closely, if you can see, there's commas over here. Whoops. There's small commas over here. Let's change it back to star dash. There we go. You have many, many options for changing how you want to view this graph. Okay. We will show them later though. But this is how you can create multiple plots on the same canvas using plt.subplot. Now, Matploitlib object-oriented method. Before we go forward, does anyone remember what an object-oriented programming language is? Guys?
Programming language in which you can directly define objects and classes.
Yes, correct. You can directly define objects and classes. Now, in Matplotlib, object-oriented does not have any classes or whatever. It's just graphs. But you can manipulate whatever objects you create, regardless of what graph it is. Oh God, you can manipulate it. Okay. Introduction to the object-oriented method. Let's go through this. The main idea in using the more formal object-oriented method is to create figure objects and then just call methods or attributes off of that object. Object का नाम क्या है? What is the object's name? What is the object's registration number? What is the object's size? How many columns does it have? How many rows does it have? These are all methods and attributes, and I'm calling these attributes off of the object that I've created. This approach is nicer when dealing with a canvas that has multiple plots on it, not a single line. Just multiple plots is easier because you can understand these better. To begin, we create a figure instance, then we can add access to that figure. We create an empty canvas called fig equals plt dot figure. Now this dot figure, what it does, it just creates an empty canvas that you can manipulate later. Before you saw, we can use plt dot plot to simply start plotting. Here, you create a simple canvas first. Okay, let us just a equals plt dot figure a dot show. Is non-interactive and thus cannot be shown. Since there are no objects on this figure, it is nothing. It is literally emptiness. It is depression. It is dead, basically. Therefore, you cannot access it yet. So here we've created an empty canvas first. You added a set of access to this figure. If you add these access, then at least it can be seen. Now, 0.1, 0.1, 0.8, 0.8. These are from a range of 0 to 1, left, bottom, width, and height. So 0.1 will be the distance from the left, 0.1 will be distance from the bottom, 0.8 will be the width, and 0.8 will be the height. If I set the width and height to 1, 1, you see it becomes bigger. That's all it does. I want to make them a little bit shorter. Too big you are becoming. Comma 0.5. Chotu graph. Very cute. Let's stick to 0.8 and 0.8. Reasonable size. Plot that set of axes, plot on the set of axes that we've just created. So what we do is axis dot plot of x comma y comma green. Again, I don't like how green is looking. I'm going to do it blue, right? Set X label, set Y label, set title. You've seen these before. You know how you can change the X labels, Y labels, and titles now. Remember these functions, and if you ever have any doubts, just go through Matplotlib or MATLAB's official documentation. You'll get a hint of the other from each of these, right? Very simple to understand. Um, you see you've created a nice little graph over here using an empty canvas and then adding axis and then creating your graph however you like. Code is a little bit more complicated, but the advantage is that now we have full control of where the plot axes are placed, and we can easily add more than one axis to the figure. Now, what does this mean? The original code for writing this, how you can manipulate these figures, is a little bit more complicated, but fine, that is fine, because this gives us leverage. This means that we can use these axes or these graphs however we want to. We can keep adding on to the figure. You see over here, there's a stuffed graph inside a very big graph. I want to change that. I want to make the outside graph a little bit bigger. I've made the outside graph bigger and the inside graph space, I don't like it. I want it to be smaller. 2.2 times 0.4. And you see, it becomes smaller and it becomes very nice to view. Therefore, you see, you can change how you look at these graphs with just one simple parameter change. Just give me 1 second, please. Bottle wasn't closing. All right, thank you. Now you can obviously manipulate these however you want. I want the blue line to not be a line. I want it to be dashed. There we go. Dash, 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 dash. I want the red line to not be red. I want it to be yellow. I don't know if it accepts Y as yellow. Oh, it's like darker yellow. Okay, I didn't know this. But yes. And then you can set X label, set Y label, set titles again, however you'd like to. It's two title, X is two title. Why is there two of these? It's two, this is one title. Perfect. Axis one, axis one, axis one, axis two, axis two, axis two. There we go. Okay. Is this understood? All right. Thank you. One thumbs up was enough. Subplots. Again, we've seen what subplots is. You've created multiple slots on the same canvas using this subplot. And
Actually, I have a question about the color value when we plot. Can I ask that? Yeah, so actually, I remember when I had used CSS, in that we can actually directly set the color by setting up the RGB values,
hex
which
code,
should
no?
fall under like 128. So how can we do it in this instead of
1
writing the
second.
color name?
We have that option right over here. We will get through it later. But you can just put color equals whatever your hex code is. Okay. And you can change your color wherever you want to. We were about to get to that. I was about to go through why singular colors repetitively was boring. But yes. Okay, is that understood? We'll go through it in a few seconds, all right?
Yes, understood.
Yep, no problem. So subplots. PLT.subplots object will act as a more automatic access manager. What is an access manager? What is an axis? Axis is either x-axis or y-axis. Either you look at it seedha or you look at it tail. That's it. Basic use cases. How do you use this basically? Use similar to plt.figure, except use tuple unpacking to grab figure and axis. What is tuple unpacking? You're using this function and you're putting multiple parameters over here, multiple objects over here. You're creating this function with respect to both of these objects. One is your blank canvas, The other is your axis data. These. All you've done is you've created a subplot using both of these. That is all that is. Okay. Remember the concept of this. You don't have to use it anywhere. You can simply use this method because this is more convenient. Okay. Axis.plot x comma y comma r, axis.set x label x y label y, title. And you've created a simple plot. Also remember, every plot shown over here is y equals x square. You see 1 equals 1, 2 equals 4, 3 equals 9, 4 16, 5 25, and so on. Okay. If I wanted to do y equals x cube, I could have done that, but I'll have to run everything together. I'll do it at the end, right? I'll change the equation and show you how it works. There we go. This is where we were. Then you can specify the number of rows and columns while creating the subplots object. Again, just like this, I'm going to create the subplots object again, but I'm going to put n rows equals 1 and n calls equals 2. So the number of rows I want is 1, number of columns I want is 2. Boom. Okay. Now I have 2 columns, 1 row, and you see, obviously, the 1 row will be divided equally for both because they're 2 different graphs. What if I change it to 3 columns? What if I change it to 10 columns? No, this looks ugly. 2 columns is fine. Axis is an array of axes to plot on. Obviously, we've created these axes using this. And then we can iterate through this array. Whatever the number of values in axis is, we can go through them. For AX, which is an item, just item in axis, item, 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 item. I don't know why I changed this code to set AX because it runs the same thing, just item is easier to understand, right? For any item in axis, item.plot x comma y comma b, item.set x label x, set y label y, set title. So what it does is for the first axis, it sets it to x comma y comma b, then changes x label, changes y label, changes the title. And for the second object, again, it does the same thing. Obviously, if you want to change them individually, you'll have to do something like this. You'll have to use the concept of multiplots if you want to change them to be differently placed, But yes, for subplots, if you want multiple plots of the same kind, this is what you do. Again, let's create another one. Figure, comma, axis equals plt.subplots, n rows equals 1, n calls equal 2. For ax and axis, ax.plot, xyg, whatever. And then I do plt.tight layout. What is this tight layout? Go over here, you can see we can use fig.tight layout or plt.tight layout method, which automatically adjusts the positions of the axis on the figure canvas so that there is no overlapping of content. Here you can see by default there is no overlapping of content, but you can see that this Y over here is very closely packed. Gives me some kind of OCD disorder, If you do tight layout, it simply spaces them better. See this? See the difference? This one looks much nicer. If I were to create one with, say, 3 columns. God, over way. 3 columns. Created one with 3 columns. You see there's some kind of overlapping over here. I do axis again. I iterate through them. You see there's this sort of overlapping. You see the Y is going inside the other graph. Why do you have to do so much, Kujali? Simply do this. Wait. Oh God. 3 columns. Simply do this, and you see that the spacing will become much better looking. Okay. That's all you have to do. You have to do tight underscore layout, and it will look much prettier. It's like when you use online GDB and you forget to put tabs in between your code. Is there anyone here who uses online GDB? It is an online compiler for programming languages, whatever language you want to code on. Sorry. Anyways, there is an option to beautify your code, which means it will automatically put tabs, it will automatically put spacing. It'll make your code look visually prettier. This is similar to that. It just makes your graphs look visually prettier, tight layout. And then we go to figure size, aspect ratio, and DPI. Any gamers over here that can tell me what DPI refers to? Because it is usually a gamer term.
Dots per inch.
There we go. Valorant and all you play, no? Anyways, figure size, aspect ratio, and DPI. This is basically telling you how you can look at your graph. How can you look at your graph better? Matplotlib allows the aspect ratio, dots per inch, and figure size to be specified when the figure object is created. Quickly, for the people who may not know, Mihir, can you tell me what DPI is? Like what dots per inch refers to?
Usually, if I'm talking about like mouse, it will refer how what is the sensitivity level of mouse at like till what motion it will make a small step. Will the mouse be able to detect that movement?
Okay, you are correct. Yes. It refers to how many pixels are moved if I move 1 inch of my mouse. So I move my mouse right by 1 inch. You can see how many pixels it has moved, correct? That is what DPI is. Over here, it just shows per inch how many dots or how many pixels should be displayed. You see this? DPI is the dots per inch or pixel per inch, right? Just shows you basically another way of depicting how big or how detailed your graph is going to be. So you create another figure, plt.figure of fig size 8,4. 8,4 are just random values that you're using to create your figure size, and DPI I've set it to 100, which means there'll be 100 pixels per inch. That is how expanded it will be. Let's create a figure size of 12,3. That is this long and this wide. And then we do x comma y comma r, x comma y, and title. These are, excuse me, these are your basic stuff, right? plt.figure fig size. You have changed this in figure. What if I do DPI equals 200? Then set this. You see a little bit of a difference? No, you don't, because the number of pixels is the same. Okay. Maybe I need to change the figure size. Anyhow, let's continue. Dots per inch does not matter that much. Figure size is what matters, because 8 times 4 is, if I change to 8 times 5, then do this. This does not matter right now because the axis have not been changed. If I do 5, there we go. Okay. Saving figures. Matplotlib can generate high quality output in a number of formats, including PNG, JPG, EPS, SVG, PGF, PDF, whatever. You can save your figures. This is a very pretty looking figure. I want to save it. How do I do it? I do it as fig.savefig filename.png. And then I can specify the DPI or dots per inch over there. That just this explains how well resoluted the quality of my graph is going to be. So if I want HD quality, I can do 1920 by 1080 resolution, and the DPI can be around 480 pixels. Okay, you can change it like that. You know your 1080p, 480p, these are all pixels per inch. How many pixels there are? 1080 pixels per inch, 480 pixels per inch, 240, etc. You know how you watch your videos on YouTube now. That's the same thing. Legends, labels, and titles. We've been seeing this for ages now. You see X label, Y label, and title. What is a legend? Can anyone tell me in a graph what a legend is?
Like if there are multiple types of data that you are displaying, like there are multiple blue line, there's red line. So you can through legend show that what does the red line represent and what does the blue line represent and so on.
Absolutely correct. That is what a legend does. It represents all the different types of data sets in the graph of yours. You just want to you want to tell your people what is this, instead of telling them to look at the X label, look at the Y label. All they can do is look at a small box on the top left of the graph or top right of the graph, wherever, and they can see what each line means. That is a legend. Labels and titles, we've been seeing this so far. Figure titles can be set using set title, figure access labels can be set using X label and Y label. Legends. You can use the label equals label text keyword argument when plots or other objects are added to the figure, and then using the legend method without arguments to add the legend to the figure. So I create a new figure, plt.figure, figure.add access 0011. That's you've added a 1 by 1 access over here. That's it. Ax.plot x comma x square and x comma x cube. Label equals x square, label equals x cube, and ax.legend. Now, if I want to do that and that, you see how it changes over here? If I do, oops, that, and this is my increasing rate of happiness, and this is my increasing rate of sadness. Yeah, you know what? I don't like this. There you go. So you can change your labels accordingly, and then your legend can be renamed. Okay. Notice how legends are overlapping some of the actual plotting. So sometimes over here, if you put your y equals 0, sorry, x equals 0 line, boom, you have a very big line over here, x equals 1. It might interrupt your legend over here. No? So how do you relocate your legend? There are a number of options. If you do ax.legend of loc equals 1, puts it in the upper right corner. So if I do loc equals 1, see, there it goes. 2, left. This is by default. 3, bottom left. That's the ugliest position to put your legend, by the way. Never do that. Either in your MATLAB code, Matploitlib code, or in real life. Just move this, and the system will choose it for you by default. If you do loc equals 0, Matplotlib usually decides the optimal location. Or if you put nothing in here. There we go. It knows that over here there's plot, over here there might be some plotting, over here there is plotting. Why take a risk? Just put it over here, right? Remove this, do that. Perfect. Setting colors, line widths, line types. Someone had a doubt about the colors, and that will be solved right over here. There is the basic MATLAB-like syntax, which I would suggest you avoid for more clarity's sake. Oh my God, I don't type that bad. Thank you. I surprise myself sometimes. Um, Colors with MATLAB-like syntax. With Matplotlib, we can define the colors of lines and other graphical elements in a number of ways. First of all, we can use the MATLAB-like syntax where B means blue, G means green, Y means yellow, R means red, whatever. The MATLAB API for selecting line styles is also supported where, for example, B dot dash means a blue line with dots. You'll see a number of examples over here of everything that is possible. I'll go through this code later. Wait up. Okay. So figure comma ax equals plt dot subplots ax dot plot this ax dot plot this. You have a blue dotted line and a green dashed line. So what if I switch these? You see how they become dashes with dots? There's a number of possibilities here. What if I put star and dots? You can't do that. Let's go back to this. What if I put a dash with commas? Oh, you can't. Okay. Try to put a comma with dots. Oh, the commas are so small you can't see them. Okay, that is an issue. What if I do? Nah, you can't do that. I am just messing around. There are a number of possibilities here, which will be shown right over here, line and marker styles. But yes, this is an example. Colors with the color equals parameter. We can also define colors by their names or RGB hex codes and optionally provide an alpha value using the color and alpha keyword arguments. Alpha indicates opacity. And obviously opacity means how transparent or how opaque it is. Now let us do x dot plot x equals x plus 1, x comma x plus 1, color equals blue, alpha equals 0.5. You see, this is half transparent. We run this code again. If I do alpha equals 1, sorry, not 2, 1, see how bright that is? But if I change it to 0.1, you see the difference. Let us change this to 1 again. And how about D3498 C? Also, hexadecimal code is something this supports, so make sure it does not have GHI, JK, or PQ, or whatever. And this is some kind of pink. Let's try something with B. B, 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 B. How about that? That's great. How about A, 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 A? That's gray again. Oh, okay. Prefer to that. But if I do that. I hope that solves your doubt. Color guy. Who was the color guy? Sorry.
Actually, my doubt was like in CSS, we can do like RGB and then in brackets we will put their values individually, like value for R, then value for
Oh,
B, and then
okay, okay, okay. I know what you mean. Yeah, 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 I get what you mean. No, Matplotlib does not support that. It supports hex code, but it does not support that RGB thing, right?
okay, understood. Thank
Yeah,
you.
yeah, yeah, no problem. Uh, okay. Now we got line and marker styles. As you've been seeing over here, I've created a starred line, a dashed line, whatever. How many such lines are there? So you got lines type options as dash, double dashes, dash dots, colons. You can change them to colons as well if you'd like. You want to see this? You can just do, and you see they're dotted lines, right? Then you see the colors red, line width. Different line widths are basically how thin and thick you want them. So the first things you have are x plus 1, x plus 2, x plus 3, x plus 4. That's the bottom four lines with different line widths, all in the color red. X dot plot x plus 5, 6, 7, colors green. Line width equals 3. You see LW, that's just line width. And line style, or LS, equals however you want the line style to be. You need to specify everything over here. So you have colons, which is dotted lines. You have dash dot, which is dashes with dots. And you have a single dash, which is a single dashed line. You see that 5. Then starting at 8, we have custom dashed lines, which are line comma equals x dot plot. You see over here, line comma nothingness, which means there is no second argument in this segment. Okay, you remember tuple indexing that we've done before? There is no second tuple over here, it's just line. If I remove this, it won't work. I put that in, it will work. Ax dot plot of x comma x plus 8, color black, line width equals 1.50. There we go. Then we keep going, set dashes 5, 10, 15, 10. So that is how you can set the dashes to stop at wherever you want it to be. Okay. Possible marker symbols. You can mark your points like every single spacing with pluses, O's, S's, ones. You can see them in the depths over here. I need to look very deeply into my computer screen, but you can see that these 4 lines have different markers over here, the blue lines. Okay. Finally, we have your purple lines, which have different markers. You have O's, but they're differently sized. And at the end, you've got very long piece of code. Look at this segment. X comma X plus 16, that's the 16th line. Color equals purple, it's purple in color, the line. Line width equals 1, let me change that to 3. There you go. Line style equals dash, so it's a single dash line. Marker equals S, you've marked them with S's. Marker size equals 8, very big markers. Marker face color equals yellow. Marked width equals 3. So the fact that it's been marked, you're just making a border around it, and the width of that will be marked by 3. And marked color is green. Okay, I hope all of these are understood. There are several different arguments over here that you can put for setting your colors and line widths and line styles and markers, regular widths, how to put in your multiplots, whatever. And all of that will be available on Matplotlib's official website. Since today is the last class, I am going to put all of the material that I've used to showcase these things to you guys. And you can go through them as you want. And you can use them however you want in order to complete your assignment, which will be assigned tomorrow. Sorry, not the assignment, the mini project. Okay. Now, control over axis appearance. We will look at controlling axis sizing properties in a Matplotlib figure. What are your axes? Your x-axis and your y-axis. One seedha, one teda. We can configure the ranges of the axis using the set y-lim and set x-lim methods in the axis object, or axis of tight for automatically getting tightly fitted axis ranges. You saw before we use something called, where is it? I forgot where it was. 1 second. Of course, sorry, we used a function that told us that we can put the figures however we want. Yes, tight layout. There we go. So I couldn't find it for a second. What does tight layout mean? It means that the program itself will select for me and it will tell me what is the best method of viewing your graph. So similarly, you can set your axis to look tight so that they look prettier visually. Okay. Figure comma axis equals plt dot subplots of 1 comma 3. Figure size equals 12 comma 4. Figure size is how big your figure is going to be. Let's make it a little bit longer. 12 comma 6. There we go. And 1 comma 3 is basically the number of segments. 1, 2, 3 segments. Axis of 0. Here your indexing axis. So here, since you have 3 axes, 0 is the first one. Dot plot x comma x square comma x cube. So you've plotted 2 graphs, one for x square, one for x cube. Axis of 0 dot set title default axis ranges. Now notice this, when you change when you add a number of graphs over here, it is not the same color. So Matplotlib will automatically assign a different color to every line. So if I do maybe comma, first one, see if it takes another argument, comma x bar 4. You see a fourth line has appeared with a different color again. By default, these colors are set to whatever, but you can change these colors using the color function. I'm not going to do it because I'm too tired. X comma x to the power 5. And I can keep going. So I'm just going to go back to this. Boom. Okay. Axis 1 dot plot x square x cube. Axis equals tight and set title tight axis. So over here, the axis, I don't think you can see much difference, but the axis here will be set tightly, which means visually these are meant to look more pleasing. Okay. By default, obviously, it has been set to a value such that it is not disturbing anything. But these are supposed to be the tightest fitted axis possible. Then you do set ylim and set xlim. You change the values. So you're viewing only from 0 to 60 vertically and from 2 to 5 horizontally. So you're setting your y limits and your x limits. That's all you're doing, okay? And since you've done that, you can see that your graph no longer starts at 0 because there is no 0 to begin with. Okay? These are your custom set axis ranges, sorry. There are some special plot types. There are many specialized plot types we can create, such as bar plots, histograms, scatter plots, and much more. Most of these types of plots we will actually create using Seaborn. Now, Seaborn is another module in Python, which is a statistical plotting library. It is used for analyzing and visualizing large data sets. So you have a large data set. How do you want to view it? That is where you use Seaborn. If you want to view it using a 3D bar plot or a 2D histogram, whatever, you can create something like that using Seaborn, but you don't need it much or in Matploitlib. This is just an introduction of how the machine learning model can be implemented using Python. That is what you do. This is a scatter plot. What a scatter plot is, your values have randomly been scattered, x comma y. What are x and y? Y is equal to x squared now from your given value. 1 is 1, 2 is 4, 3 is 9, 4 is 16. You see how these values have been randomly just scattered. If I change this to R, no, I can't do that. There we go. Just stick to that for now. Uh, why I can't do that is because some graphs over here have different functions and different arguments for each of them. If you want to go through them, again, you'll have to go through the official documentation to see which method has what functions, etc. There we go. Now, from random import sample, from what sample is basically you're just getting yourself a random data set and you're putting it in the range of 1 to 1000, 100 of these, okay? Then you create an array of this and assign it to the value data. Then you do plt.hist. What hist is it's a histogram of data. These are your values 9, 12, 10, 6, 10, 12, 9, 6, 5, 9, sorry, 15, 11. And then you have your alternate array saying 7, 10, 100, 105.5, 204 point nothing, 302.5, 401, etc. And you can see this histogram changing accordingly at these places. It starts at 0. It starts at 0 and goes to 9. Then exactly after 7, sorry, starts here at 7. Yes. You see, it does not start exactly at 0 because this array says 7. It starts at 7. Then it at 100 of 5.5, it goes to 12. Then at 204, you see it come back to 10 and so on. So this is how a histogram goes. Okay. Box plot. What a box plot is, data equals numpy.random.normal 0, std, 100 for std in range 1, 4. So it takes values from 1 to 3. So 1, 2, and 3. And it just gives you 3 random normal values. Then you create a box plot for that. Data vert equals true and patch artist equals true. And this is the box plot for that. This gives you random values for 1, 2, 3. And you can see them plotted right over here. This is the range that you're getting. These are some references for further reading. Obviously, I will send all of this to you right after the class ends. But yes, that is the end of our Python bootcamp. Your concept-based reading is all up to you. Material will be shared to you, and what the project will be based on whatever you have learned over here. Yeah, Mohammed Sharif, do you have it out? Oh, okay. Um, so yes, these are all of the concepts, and your project will be based on these concepts. So most likely, I will give you a small data set, and you will have to access it using pandas or whatever, and then you will have to create a series of plots. You will have to create a system, and it will be application based. So instead of calling it a simple, series or data set or just a random graph with titles, I will rename it. I will call it traffic analyzer, or I might call it a student analyzer, like student grade analyzer system. I might call it a bank report system. I might call it a history system, like what has happened in the last 1,000 years, the 1,000 years before that, what has happened. You may have to create graphs for all of these and access them using pandas, apply numpy arrays, linspace, range, random values, standard distribution. Everything that you've learned, all of it, you'll have to slowly apply. Obviously, all of the material that I will be presenting to you will be completely at your discretion. You will be able to use it however you want to. And you can come to me or any one of the admins here, I think, for doubts. All right. So far, are there any doubts? Obviously, there's another part over here. There is the advanced Matplotlib segment, but I figured that will be way too advanced since you don't need to go that far to begin with machine learning. But yes, it will be shared with you guys. You can start doing colored subplots. You can start doing 3D diagrams. You can see surfaces, rising, falling, however you want. You can see these in wireframe segments. You can see these in contours, for relations, 2Ds and 3Ds, whatever. Yes, all of this is at your discretion. The mini project details will be shared tomorrow. Any other doubts?
My doubt is regarding that chatbot thing.
Oh, okay. Bring it on.
I have created like 3 different chatbots and I have uploaded it in my GitHub profile as well. But if I am checking from other GitHub, like if I like from the other GitHub profile, it's not showing what
Did
I
you
have
set
submitted on my GitHub.
Okay, okay. Did you set your repository to public? Because I have not gone through any of the submitted projects yet, but all of you need to set your repositories to public so people can view them.
It is public, but it's just showing the first one. Except that the other two, it's not showing.
Maybe your files have not been publicized yet. Just check your access type for each of your files, and you can text me after. I'll let you know how to handle it. And if there's any other errors, you can just mail the files to me. That's fine.
Okay.
Right? This does not count for everyone. Everyone else needs to submit them on GitHub. I don't want my mailbox to be spammed. And yes, anything else? Any other doubts? Anyone? And yes, if you don't have doubts, you can start leaving. That's fine. Right? If you don't have doubts, you can just say no or something, please.
Actually, I had a small doubt.
Yeah. What's up?
Yeah, so actually, I had added in my chatbot the voice utility. Like when it will respond, it will also generate it won't generate, but it will play an audio output. But I generated those audio outputs, most of them by GTTS.
Hmm.
So the program that through which I generated those audio outputs, should I mention them or is it not necessary?
I
Because what I
mean,
have done, I have generated MP3 files through GTTS and then I directly included those MP3 files in the GitHub project rather
okay,
than
I
the
get what you
code through
did.
which I
Ha
generated.
ha ha. Okay, so you use GTTS and put in MP3 files just for the code to understand what
Yeah,
the
so
input
I
is.
generated, yeah, because it takes time for GTTS to generate those files. Therefore, I generated them beforehand so it can directly, program will directly play those files.
Okay, fine. I get what you did. This reminds me of a project I did back in class 9. I did the same thing as you did. I uploaded MP3 files as well. So, anyways, yeah, that is completely fine. You don't need to mention it. I will go through it. It is on your GitHub right now, yes?
Yes.
Okay, okay. I will
Actually,
go through
whenever
them.
something
Huh.
new comes in my mind, so I'm also making commits to it.
Okay, okay, very good. Keep committing, keep pushing. I mean, that is exactly how GitHub works. So yes, good job.
Okay, thank you.
No problem. Anyone else with any other doubts?
Okay, then we can leave then, Deepto.
Yep.
No one
Okay.
has any doubts.
Everyone, thank you so much for joining. Thank you for being patient with me. I hope you guys had a wonderful experience. I kind of had a wonderful experience. I thought it was pretty fun. I thought it was the same for you guys as well. I hope so. I hope it was the same for you guys as well. Um, yeah, well, I wish you guys all the best with your mini project and the assignment that was given to you. Do very well. Make me proud. You're very happy. I don't know, bhaiya. Don't ever call me sir, please. And yes, good night. Thank you.
Thank you. Good night.
Thank you. Good night. Stop recording.